From fabric and wood biplanes to supersonic stealth fighters, these are the aircraft that didn't just fly. They changed everything about how we fly. Early aviation pioneers. Wright Flyer, December 17, 1903, at Kitty Hawk, North Carolina. 12 seconds, 120 feet. That's all it took to change human history forever. The Wright Flyer proved that powered, controlled, heavier-than-air flight was possible. Before this moment, it was theory, experiments, and dreams. After it, aviation was real. The Wrights didn't just get lucky, they solved the problem of control that had defeated everyone else. Their wing warping system allowed turns, the elevator provided pitch control, and that little 12-horsepower engine provided just enough thrust. Yes, it barely flew. Yes, it was fragile. But it worked. Everything that came after, every airliner, every fighter jet, every spacecraft, traces its lineage back to those 12 seconds over the sand dunes of North Carolina. Blériot-11. Louis Blériot crossed the English Channel on July 25, 1909, flying from France to England in 37 minutes. It doesn't sound revolutionary until you realize what it meant. Britain was no longer an island. The natural defense that had protected England for centuries was suddenly obsolete. Blériot's tiny monoplane proved that aircraft could travel distances that mattered, that they weren't just fairground attractions. Military leaders around the world suddenly understood that future wars would include air power. The Blériot-11 was fragile, underpowered, and nearly crashed on landing, but it changed strategic thinking forever. Fokker-Eindecker, the first true fighter aircraft, and it terrorized Allied pilots in 1915. Anthony Fokker's synchronization gear allowed a machine gun to fire through the propeller arc without shooting the blades off. Suddenly, pilots could aim the entire aircraft at their target and fire. Before this, combat meant awkward mounted guns or pistols shot from the cockpit. The Eindecker created the concept of the fighter pilot, the ace, the dogfight. It gave Germany air superiority for months during the Fokker scourge. Allied pilots desperately sought to avoid the Eindecker until they developed their own synchronized guns. Aviation warfare was born from this innovation. Junkers J.I, the world's first all-metal aircraft to see combat, introducing corrugated duralumin construction. Before the J.I, aircraft were fabric and wood, fragile and flammable. Hugo Junkers proved that metal construction was viable, creating a ground attack aircraft that could survive punishment that would destroy conventional designs. The corrugated metal became Junkers' trademark, used on aircraft for decades. The J.I wasn't elegant, it was heavy and slow, but it survived. It showed that aircraft could be built like machines, not like kites with engines. Modern metal aircraft construction traces directly to Junkers' innovations. First practical aircraft. De Havilland DH.4. The first practical purpose-built bomber to see large-scale production, combining speed, range, and bomb load in a way that previous aircraft couldn't match. The DH.4 could fly higher and faster than many fighters, making it difficult to intercept. America built thousands under license, and it remained in service into the 1930s. The DH.4 established that bombers were viable, that you could build aircraft specifically to carry weapons deep into enemy territory. It created an entire class of military aviation. Curtiss JN-4 Jenny. This wasn't revolutionary in technology, but in impact. The Jenny trained tens of thousands of pilots during World War I, then became the barnstormers' aircraft of choice in the 1920s. Cheap war surplus Jennies brought aviation to the American public, giving rides at county fairs and performing stunts. The Jenny created America's aviation culture, inspiring a generation of pilots and engineers. Without the Jenny, aviation might have remained an elite pursuit rather than a national passion. Jet Age Revolution. Heinkel He, 178, August 27, 1939, the world's first flight of a turbojet-powered aircraft. Erich Vorsitz took off from Rostock-Marienäher in Germany, and aviation changed forever. The He 178 wasn't practical. It flew for only a few minutes and was never developed further. But it proved that jet propulsion could work, that aircraft didn't need propellers. Hans von Ohain's turbojet engine opened a new frontier in aviation. Yes, Frank Whittle developed jet engines in Britain simultaneously, but the He 178 flew first. Every jet aircraft since owes its existence to that first flight. Messerschmitt Me 262, the world's first operational jet fighter, and it was decades ahead of its time. When Allied pilots first encountered Me 262s in 1944, they couldn't believe what they were seeing. The German jets flew 100 Mphs faster than anything the Allies had, could climb faster, and carried heavy armament. A properly flown Me 262 was nearly untouchable by Allied fighters. Only Hitler's interference, fuel shortages, and overwhelming Allied numbers prevented the Me 262 from achieving air superiority. The Me 262 showed what jet fighters could do, inspiring post-war American and Soviet jet development. Captured Vita 262s influenced the F-86 Sabre and MiG-15 designs. It proved that the future of aviation was jets. Gloucester Meteor, Britain's first operational jet fighter, entering service in 1944. While the Me 262 gets more attention, the Meteor had better reliability and a longer service life. It shot down V-1 flying bombs, set world speed records, and remained in service for decades. The Meteor proved that jet fighters could be practical, reliable, and maintainable, not just experimental terror weapons. British jet engine technology, particularly the centrifugal compressor design, influenced American jets like the F-80 and F-84. De Havilland Comet, the world's first commercial jet airliner, entering service in 1952. The Comet was beautiful, fast, and revolutionary, cutting travel times in half. Passengers loved the smooth, quiet jet experience compared to propeller aircraft. For a brief moment, Britain led the world in commercial aviation. Then disaster struck. 3 comets disintegrated in mid-air due to metal fatigue around windows. The crashes grounded the fleet and destroyed public confidence. By the time the problems were fixed, Boeing and Douglas had learned from Comet's mistakes and dominated the market. The Comet's tragedy taught crucial lessons about pressurization cycles and metal fatigue, making every subsequent airliner safer. It failed commercially, but succeeded in pioneering the jet age. Boeing 707. This is the aircraft that created modern air travel. The 707 was fast, reliable, efficient, and could cross the Atlantic non-stop. When it entered service in 1958, it transformed commercial aviation from an elite luxury to mass transportation. The 707's swept wings, podded engines, and pressurized fuselage became the template for every jet airliner since. Pan Am's 707s shrunk the world, making international travel routine rather than extraordinary. The 707 made Boeing the dominant airliner manufacturer for decades. More than that, it changed how humans travel, enabling tourism, international business, and global culture as we know it. Supersonic Breakthroughs. Bell X-1, October 14, 1947. Chuck Yeager broke the sound barrier over the Mojave Desert. The X-1, shaped like a .50 caliber bullet, was dropped from a B-29 and rocket-powered to Mach 1.06. Before this flight, many engineers believed the sound barrier was an actual wall that aircraft couldn't penetrate. Yeager proved them wrong. The X-1's data taught engineers how to design supersonic aircraft, what shapes worked, how shock waves behaved. Every supersonic aircraft since, from fighters to Concorde, exists because the X-1 showed it was possible and provided the aerodynamic knowledge to do it safely. North American F-100 Super Sabre. The first fighter capable of sustained supersonic flight in level flight, not just dives. When the F-100 entered service in 1954, it represented a quantum leap in capability. Fighter pilots could now routinely operate beyond Mach 1, fundamentally changing air combat. The Hun had problems. Early models suffered from dangerous pitch-up characteristics that killed pilots. But once fixed, the Super Sabre established supersonic performance as the standard for fighters. It proved that supersonic capability was practical for operational aircraft, not just experimental research planes. Lockheed F-104, Starfighter, Mach 2 in a fighter aircraft. Kelly Johnson's missile with a man in it pushed technology to its limits. Those tiny straight wings and needle-like fuselage created an aircraft that could reach twice the speed of sound and climb like a rocket. The F-104 was unforgiving, killing hundreds of pilots, particularly in German service. But it demonstrated that Mach 2 was achievable in a production fighter. The Starfighter influenced high-speed fighter design worldwide, showing that speed could be prioritized even at the cost of maneuverability. It set world records and proved that supersonic performance could be pushed further than anyone thought. Aerospatial BA's Concorde. Supersonic passenger travel. London to New York in 3.5 hours. The Concorde represented the pinnacle of 1960s technological optimism, the belief that supersonic travel was the future. It was beautiful, impossibly elegant with that ogival delta wing and drooping nose. Passengers paid premium prices to fly at Mach 2, arriving before they left in clock time. But economics killed it. The Concorde was expensive to operate, incredibly loud on takeoff, and banned from supersonic flight over land. Only 20 were built, operating for just 27 years before retirement. Yet the Concorde proved that supersonic passenger flight was possible. It remained the only supersonic airliner for decades, a technological achievement that we've failed to replicate. The Concorde showed both the promise and limitations of pushing commercial aviation to extremes. Tupolev Tu-144, the Soviet Concorde, actually flying commercially before its Western counterpart. The Tu-144 looked similar to Concorde, leading to accusations of espionage, though Soviet engineers insisted on independent development. It was faster than Concorde, reaching Mach 2.3, but much less refined. The Tu-144 suffered from reliability issues and a catastrophic crash at the 1973 Paris Air Show. Commercial service was brief and troubled, yet the Tu-144 proved the Soviets could match Western supersonic technology, demonstrating that the space race extended to commercial aviation. Strategic bombing evolution. Junkers Ju-52. This trimotor transport created modern airlift capability. The Ju-52 could carry troops, cargo, or casualties, operating from rough fields in all weather. It pioneered military airlift, enabling rapid deployment of forces by air. The Ju-52 proved that aircraft could support armies logistically, not just tactically. Germany's invasion of Crete relied on Ju-52s dropping paratroopers, the first major airborne assault. The concept of air mobility, of armies supplied by airlift, began with the Ju-52. Boeing B-17, Flying Fortress, strategic daylight bombing. The B-17 was designed to fly high, in formation, defending itself with massed firepower while dropping bombs with precision. American doctrine believed bombers could win wars by destroying enemy industry. The B-17 was tough, famously absorbing terrible damage and bringing crews home. Yes, losses were horrific, particularly early in the war. But the B-17 proved that strategic bombing was viable, that you could strike the enemy's ability to make war. The B-17 and its crews created modern air-powered doctrine. Avro Lancaster, Britain's answer to strategic bombing. The Lancaster could carry heavier bombs than any American bomber. It carried the 22,000-pound Grand Slam, the largest conventional bomb of World War II. Lancasters destroyed dams, ships, and cities in night raids that devastated German industry. The Lancaster proved that heavy bombers could deliver massive payloads accurately. Its success validated British night bombing doctrine and showed that strategic bombing worked, if brutally. Boeing B-29 Superfortress, the most advanced bomber of World War II and possibly the most influential. The B-29 was pressurized, allowing crews to fly at 30,000+ feet in comfort, while unpressurized fighters struggled to intercept. It had remote-controlled gun turrets, advanced fire control systems, and incredible range. B-29s firebombed Japanese cities, destroyed industry, and finally dropped the atomic bombs that ended World War II. The B-29 represented the peak of piston engine bomber technology, so advanced that it influenced jet bomber design. The Soviet Tu-4 was a direct copy, jump-starting their strategic bomber program. The B-29 proved that technology could create unassailable weapons platforms. Boeing B-52 Stratofortress, the buff, big ugly fat fellow, has been flying for over 70 years and will likely reach 100 years of service. The B-52 was designed as a high-altitude nuclear bomber, but evolved to low-level penetration, then standoff missile carrier, then conventional carpet bomber, and now precision strike platform. B-52s flew in Vietnam, the Gulf War, Afghanistan, and every conflict since. What makes it revolutionary? Adaptability. The B-52 proved that a good basic design could be continually upgraded to remain relevant across generations of technology. Those 8 engines and massive airframe create a weapons platform that can carry any payload America develops. The B-52 is the last bomber that will ever have a human name. Every B-52 pilot knows their aircraft's individual history, its missions, its quirks. It represents the last generation of bombers built in large numbers, operated by crews who knew their aircraft personally. Commercial aviation revolution. Douglas DC-3, the aircraft that made commercial aviation profitable. Before the DC-3, airlines lost money on every flight, surviving on government mail contracts. The DC-3 was reliable, economical, and comfortable enough that passengers would choose to fly. It could operate from short runways, carry 21 passengers, and fly coast to coast with only 3 stops. By 1939, 90% of airline passengers worldwide flew on DC-3s. World War II saw thousands built as the C-47 Skytrain, dropping paratroopers on D-Day and supplying armies worldwide. After the war, surplus C-47s became cheap airliners for developing nations. The DC-3 created global air travel, proving that aviation could be a business, not just an adventure. Many still fly today, 80+ years later, a testament to Douglas's brilliant design. Lockheed Constellation. The Connie was the most beautiful airliner ever built, with its distinctive triple tail and graceful curves. More importantly, it pioneered long-range pressurized airline service. TWA's Constellations flew non-stop across America in pressurized comfort, making air travel luxurious rather than endurance. The Constellation proved that airlines could offer comfort comparable to trains while being far faster. It created the golden age of air travel, where flying was an experience, not just transportation. The Connie influenced every subsequent airliner's emphasis on passenger comfort. Boeing 747. The jumbo jet changed everything. When the 747 entered service in 1970, It was twice the size of any previous airliner. That distinctive hump and 4 engines made it unmistakable. The 747 made international travel accessible to ordinary people, not just the wealthy. By dramatically increasing capacity, it lowered ticket prices. The 747 created mass international tourism, global business culture, and connected the world like never before. It was the first wide-body airliner, creating 2 aisles and unprecedented space. The 747 served as Air Force One, carried the space shuttle, and became synonymous with air travel itself. For 50 years, jumbo jet meant 747. Boeing bet the entire company on its success, and it paid off, dominating long-haul travel for decades. Airbus A300, Europe's first wide-body airliner, but more importantly, the first commercial twin-engine wide-body. The A300 proved that 2 engines were sufficient for long-range flights, challenging Boeing's 4-engine orthodoxy. It pioneered ETOPS, extended-range twin-engine operational performance standards, allowing twin-engine aircraft to fly routes previously requiring 3 or 4 engines. The A300 was more fuel-efficient than 4-engine competitors, cheaper to maintain, and just as safe. It established Airbus as a viable competitor to Boeing, creating the duopoly that defines commercial aviation today. The A300's success proved that European collaboration could challenge American dominance. Boeing 777, the first fly-by-wire Boeing, the first aircraft designed entirely with computers, and the first to be certified for ETOPS from entry into service. The 777 was revolutionary in how it was designed, using digital tools to virtually test every system before metal was cut. It could fly long overwater routes with just 2 engines from day one, something previously unthinkable. The 777's efficiency made 4-engine aircraft obsolete for most routes. The GE90 engines that powered it were the most powerful jet engines ever built. The 777 represents modern airliner design philosophy. Twin engines, fly-by-wire controls, digital design, incredible efficiency. It proved that computers could design aircraft better than humans alone. Vertical flight revolution. Focke-Wulf FW-61, the world's first practical helicopter, flying in 1936. Igor Sikorsky gets more credit in America, but Heinrich Focke's design proved that helicopters could be controlled, stable, and useful. The FW-61 set helicopter records for altitude, endurance, and speed. It demonstrated hovering, precise control, and vertical takeoff. While it never entered production, the FW-61 proved the helicopter concept was viable. Every helicopter since validates Focke's pioneering work. Sikorsky R-4, the first production helicopter, entering service in 1942. Igor Sikorsky perfected the single main rotor with tail rotor configuration that became the helicopter standard. The R-4 was used for rescue missions in World War II, proving that helicopters could save lives in situations where fixed-wing aircraft were useless. It was slow, short-ranged, and underpowered, but it worked. The R-4 created the helicopter industry, showing that rotary-wing aircraft were practical military and civilian tools. Every helicopter manufacturer owes their existence to Sikorsky's success with the R-4. Bell UH-1 Huey, the sound of Vietnam. The Huey didn't invent the helicopter, but it perfected the concept and proved helicopters could dominate warfare. The Huey could transport troops into battle, evacuate wounded, carry supplies, and provide fire support. It was reliable, maintainable, and produced in huge numbers. The Huey created air assault doctrine, proving that helicopters could transform how armies fight. That distinctive whoop 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 became synonymous with modern war. The Huey showed that helicopters weren't just useful, they were essential. It influenced every military helicopter since, establishing rotary-wing aircraft as a core component of military power. Bell Boeing V-22. Osprey. Take a helicopter, add airplane speed. The V-22 tilts its rotors, taking off vertically like a helicopter, then flying like a turboprop airplane at 300+ mph. The concept was brilliant, but troubled by technical problems and crashes during development. Marines and Air Force Special Operations finally got a working Osprey, able to deploy forces farther and faster than any helicopter. The V-22 proved that tiltrotor technology worked, creating a new class of aircraft. It's expensive, complex, and controversial, but it delivers capabilities no pure helicopter can match. The Osprey represents the future of vertical flight, combining helicopter flexibility with airplane performance. At stealth and advanced technology. Lockheed F-117's Nighthawk, the first operational stealth aircraft and one of the best-kept secrets in aviation history. The F-117's faceted shape wasn't elegant. It looked like it was made of flat panels because it was. Computers in the 1970s couldn't calculate radar returns from curved surfaces. The Nighthawk could penetrate air defenses undetected, striking targets while defenders watched helplessly on radar screens showing nothing. F-117s opened Desert Storm, destroying Iraqi air defenses without losses. The aircraft proved that stealth technology worked operationally, changing air warfare forever. Every modern fighter incorporates stealth features pioneered by the F-117. It showed that being invisible was more valuable than being fast or maneuverable. Northrop B-2 Spirit, the ultimate expression of stealth technology applied to a bomber. The B-2's flying wing design created minimal radar return, allowing it to penetrate anywhere undetected. Each B-2 cost over $2 billion, making it the most expensive aircraft ever built. Only 21 were produced, but those 21 could strike any target on Earth with impunity. The B-2 proved that stealth could work for large aircraft, that you could make a bomber invisible to radar. Its first combat mission was a 30-hour flight from Missouri to Kosovo and back, demonstrating global reach. The B-2 represents the peak of 20th century military aviation technology, so advanced that its full capabilities remain classified decades later. Lockheed Martin F-22 Raptor, the first fifth-generation fighter, combining stealth, supercruise, and advanced avionics. The F-22 can supercruise, fly supersonic without afterburners, giving it incredible tactical flexibility. Its stealth allows it to engage enemies who don't know it's there. In exercises, F-22s achieved kill ratios of 144-1 against fourth-generation fighters. The Raptor represents air superiority dominance, an aircraft so capable that no enemy fighter has a realistic chance against it. Yes, it's expensive and trouble-plagued. Yes, only 187 were built instead of the planned 750. But the F-22 established what fifth generation means, influencing every modern fighter program worldwide. Was Lockheed Martin F-35, Lightning II, the most controversial aircraft in history, yet possibly the most important. The F-35 program aims to replace almost every Western fighter with a common design available in 3 variants. It's the most expensive weapons program ever, exceeding $1.7 trillion over its lifetime. The F-35 combines stealth, sensors, and networking, creating an aircraft that's more computer than fighter. Critics hate its compromises, its weight, its cost, its troubled development. But the F-35's sensor fusion is revolutionary, combining radar, infrared, and data link information into a single display that shows pilots everything. It's not the best dogfighter or the fastest interceptor, but it sees everything first and shoots first. Over 1,000 have been built, equipping air forces worldwide. The F-35 represents a new paradigm. Software-defined fighters, where sensors and networking matter more than pure flight performance. Modern multi-role revolution. McDonnell Douglas F-4 Phantom II, the ultimate proof that multi-role works. The F-04 was designed as a Navy interceptor, but became the primary fighter for the Navy, Air Force, and Marines. It could intercept bombers, dogfight, strike ground targets, conduct reconnaissance, and suppress air defenses. The Phantom served in Vietnam, the Middle East, and dozens of other conflicts. Over 5,000 were built, exported to 11 nations. The F-4 proved that one excellent multi-role aircraft could replace multiple specialized types, creating the modern fighter philosophy. Yes, it was designed without a gun, a mistake. But once corrected, the Phantom established that versatility and payload matter more than specialization. General Dynamics F-16 Fighting Falcon. The lightweight fighter that changed everything. The F-16 was revolutionary in using fly-by-wire controls, allowing unstable designs that were more maneuverable. That side-mounted joystick and reclined seat helped pilots handle 9G maneuvers. The F-16 proved that a smaller, cheaper fighter could be highly effective through superior agility and technology. Over 4,600 have been built, operating with 25 nations. The F-16 established that electronics and flight control systems could overcome size disadvantages. It pioneered many features now standard: bubble canopy for all-around visibility, head-up displays, hands-on throttle and stick controls. The Viper proved that nimble, versatile, and affordable could beat expensive and specialized. Sukhoi Su-27 Flanker, the Soviet masterpiece that proved Russian designers could match the West. The Su-27's aerodynamics allow incredible maneuvers, demonstrating the Cobra maneuver and other moves Western aircraft couldn't perform. Its range is double that of most fighters, addressing Soviet geographic challenges. The Flanker established post-stall maneuvering as a design goal, influencing fighter development worldwide. It proved that Russian aerospace engineering remained world-class despite economic problems. The Su-27 family evolved into dozens of variants still in production today, becoming Russia's primary fighter export. It represents Soviet design philosophy perfected: simple, robust, and incredibly capable. From the Wright Flyer's first hesitant hops to stealth fighters invisible to radar, revolutionary aircraft didn't just advance technology. They changed warfare, connected continents, and redefined what's possible in the sky.